In this video, we will solve O-level mathematics paper 1-2. This is October-November 2018. So let's start with question number 1 is evaluate 1 over 8 plus 1 over 5. So we can take the LCM here. Since 8 and 5 do not have a common multiple, your LCM would be simply 8 times 5, which is 40. So since you multiplied by 5 here in the denominator, you will multiply this by 5 as well. So 1 times 5 plus you multiplied this 5 by 8 to get 40. So you will multiply 8 in the numerator as well. So you get 8 times 2. So this becomes 5 plus 16 over 40, which is 21 by 40. So your answer will be 21 over 40. Part B is evaluate 0.04 into 0.11. So I'll convert them into fractions. So I'll move the decimal 2 places to the right. So this becomes 4 over 100. And similarly here I'll move the decimal 2 places towards the right as well. So this becomes 11 over 100. 11 times 4 is 44 over 1, 2, 3, 4 zeros. So 1, 1, 2, 3, 4 zeros, which is 10,000. And then I can do this division. I will have to move the decimal 4 places to the left. So 1, 2, 3, 4. So this will be 0.0044. Question number 2, part A is 200 grams of spice cost 85 cents. Find the cost in dollars of 1 kilogram of this spice. So 1 kilogram, 1 kg we know is equals to 1000 gram. So 200 grams ratio price is 200 grams is $0.85. Since we are looking to find the price in dollars, I'll convert this 85 cents into dollars as well. So 200 grams is 85 and we're looking for 1000 grams. So 1000 gram would be, let's call it X. So since these are directly proportional, I'll just cross multiply like this. So I get 200X equals to 1000 times 0.85 would be 85 and then 3 times. So this is 850. So X would be 850 divided by 200. So zeros cancel out. I can divide by 5 here. So 5 times 4 is 20 and 5 times 1 is 5 and then 3 35. So you get 17 over 4. So let's divide 17 by 4. 4 times 4 is 16. 1, I can add a decimal here and this becomes 10. 4 2s are 8. 2 remainder, add another 0, bring it down, 20, and 4 times 5 is 20. So this is 4.25. So the price of 1 kilogram of the spice is $4.25. Part B is you are given 60 ratio x equals to 3 ratio 2. Find the value of x. So we can convert this ratio into a fraction. So this becomes 60 over x equals to 3 over 2. Then to find the value of x, I can cross multiply. I get 60 into 2 equals to 3x. And then 3x equals to 60 times 2 is 120. X would be 120 divided by 3, which is 40. Question number 3 is y is inversely proportional to x. So y is inversely proportional to x. So y equals to some constant k over x. Given that y equals to 30 when x equals to 1 over 3, find y when x equals to 5. So let's first use these two values to find the value of k. So y is 30 when x is 1 over 3. So k over 1 over 3. So this is actually k divided by 1 over 3, which means 30 equals to k. If I change this to a multiplication sign, I take the reciprocal here. So this is 3. So 3k equals to 30. So k equals to 10. So your equation becomes this equation here. This becomes y equals to 10 over x. So now you have to find the value of y when x equals to 5. So y equals to 10 over 5 equals to 2. So y is 2. Question number 4 is arrange these fractions in order starting with the smallest. So you have these fractions 4 over 5, 9 over 10, 17 by 20, and so on. So I can see that all these are multiples of 5. So what I can do is either I can calculate the decimal values of each, or I can make the denominator value same to make the comparison easier. So I think making the denominator value same would be easier rather than doing all these divisions and converting them into decimals. So if I make all the decimals, denominators 100, that means for this value 4 by 5, I will multiply 5 by 20. So I'll do the same in the numerator. For 9 by 10, I'll multiply this by 10 to get 100 and then multiply 10 here as well. For 17 over 20, this will be multiplied by 5. So this will be multiplied by 5. And then 21 over 25, this will be multiplied by 4. So this will be multiplied by 4. 41 over 50, this will be multiplied by 2 to get 100. And this will be multiplied by 2 as well. So this becomes 80 over 100. This becomes 90 over 100. 17 times 5 is 7 fives are 35, 3 carry. 5 ones are 5 plus 3 would be 85 over 100. This would be 84, 4 ones are 4, 4 twos are 8 over 100. And this will be 82 over 100. So now you have all the decimals are 100, so you can just simply compare the numerators and arrange them from smallest to largest. So the smallest value in the numerator is 80, which is 4 by 5. So 4 by 5 is your smallest. And then the next smallest value is this 82, which is 41 over 50. Then 84, which is represented by 21 over 25 here. So 21 over 25. And then 85, which is 17 over 20, 17 over 20, and then the largest is 90 over 100, which is 9 over 10. So now you have arranged these from smallest to largest. Question 5, part A is you have to simplify this. So I can open up this bracket. So this becomes 4c minus 6c plus 15. And then 6c minus 4c minus 6c will be minus 2c. So this becomes 15 minus 2c. Part B is you have to factorize this. So I can see that 10 and 15 are both multiples of 5, and then 8 and 12 are both multiples of 4. So I can rearrange them to write them side by side. So this becomes 8 plus 12x minus 10y minus 15xy. So out of these two, I can take 4 common. So this becomes equals to 2 plus 3x. And from here, I can take minus 5y common. So if I do that, I will get 2 here. So if I take 5y common from 10y, I'm left with 2. And then plus, because there's a minus sign here, I'll have to change the sign of this. And this is 15xy. I take 5y common, I'm left with 3x. So now I can take this 2 plus 3x common as well. So this becomes equals to 2 plus 3x and then 4 minus 5y. So this will be your final answer, 2 plus 3x multiplied by 4 minus 5y. Question 6 is f of x is given by 2x plus 5 over 3x. Find f of minus 2. So f of minus 2 is you simply substitute minus 2 instead of x here. So this becomes 2 times minus 2 plus 5 divided by 3 times minus 2. So this is minus 4 plus 5 divided by 3 times minus 2 would be minus 6. So you get 1 over minus 6. You can also write as minus 1 over 6. So this is minus 1 over 6. Then you have to find f inverse of x. So you let y equals to f of x. This means if I take this f to the other side, this becomes f inverse of y equals to x. So we'll use this later. So let's substitute f of x here. So y equals to f of x is 2x plus 5 divided by 3x. Now if I can make x the subject of the equation, I can substitute f inverse of y, which is equals to x. So let's make the x subject of this equation. I'll take this to the other side. So this becomes equals to 3xy equals to 2x plus 5. Then I'll bring this 2x here. So this is 3xy minus 2x equals to 5. Let me continue up here. So if I take x common here, this is 3y minus 2 equals to 5. And then if I divide this here, this becomes equals to 5 over 3y minus 2. Now I know that x is f inverse of y. So this gives me f inverse of y equals to 5 over 3y minus 2. And if this is f inverse of y, I can find f inverse of x by simply substituting x in place of y. So I get 5 over 3x minus 2. So your f inverse of x is 5 over 3x minus 2. Question 7 is, in a group of 35 people, 22 are wearing spectacles, 10 are wearing a hat, 6 are wearing spectacles and a hat. By drawing a Venn diagram or otherwise, find the number of people who are wearing neither spectacles nor a hat. So if I draw the Venn diagram, if this is your universal set here, and then let's represent people wearing spectacles in this red set here. So let's call it S for spectacles. And then let's draw a green one here, which is H for hat. So we know that 6 people wear spectacles and a hat. So this intersection here is 6. There are 6 people who are wearing both spectacle and a hat. And 22 people are wearing spectacles. So this whole set red here contains 22 people. So you already have 6 who wear the spectacles and the hat. So people who wear only spectacles are 22 minus 6, which is equals to 16. And then you have 10 people wearing a hat. So 6 out of them wear both the hat and spectacles. So people wearing only hat are 10 minus 6, which is equals to 4. And then you can call X number of people wearing who wear neither spectacles nor a hat. So that means, so this is an equal sign here. So that means if you add all of these 4 categories of people, your total number of people is 35. So 16 plus 6 plus 4 plus 6 plus 4 and plus X should equal 35. So 6 plus 4, 10 plus 16, 26 plus X is 35. And this gives you X equals to 35 minus 26, which is 9. So there are 9 people who are wearing neither spectacles nor a hat, which are this represented by this number X, which is outside both of these sets. Question 8 is, the diagram shows a part of a figure that has rotational symmetry of order 4 about the point O. Complete the figure. So if you have rotational symmetry of order 4, that means if you divide the full rotation 360 by the order 4 equals to 90 degrees. So that means this shape is repeated after every 90 degrees. So if I bring this up here, so this is the original diagram. So if I rotate it 90 degrees, it looks like this. So that means I have to draw towards the right, and this sort of the flag is pointing downwards. So I can do is you can measure this using a ruler so that you draw the exact same length. So I'll just estimate it here. Let me actually draw this a better way. So starting here, moving right, and the flag is pointing downwards. Something like this. And then if I rotate it another 90 degrees, which is this. So now I have it pointing downwards and towards the left. So what I'll do here is I'll draw it pointing downwards and the flag is towards the left. And then for the final one, I rotate it another 90 degrees. So that means up to 270. And the flag is towards the left and pointing up. So towards the left here and then pointing up. So what you can do is you can rotate your question paper to uh, have this similar sort of rotation that I'm doing here, and then back to full 360 degree, which is 0, and I already have it here. So let me shorten this. I think I've drawn this too long. So this here would be somewhat up till this length and then like this. So now this shape has this pattern being repeated every 90 degrees. So this will have a rotational symmetry of order 4. I can quickly show you here as well. Let me draw the shapes that I drew there. So this one like this, and then one is below like this, and then the fourth one is like this. So now if I know it's not a pretty good drawing, but you get the point. So now if I rotate it 90 degrees, the shape is exactly the same as this after I've completed it. So it has rotational symmetry of order 4 because every 90 degrees it looks exactly uh, exactly like the original figure. So another 90 degrees, again it looks the same. You have 4 flags, right, pointing right, down, right, down, left, and then up here. So back to full 360 degrees. So this is like basic definition of rotational symmetry, where your order is basically the number of times you will have the exact same figure during the full 360 degree rotation. So here, every 90 degrees, you get the exact same figure. So that means a total of 4 times during the full 360 degree rotation. So that's how you will get rotational symmetry of order 4. Part B is in the diagram, 6 small squares are shaded. Shade one more small square to give a diagram that has exactly one line of symmetry. So if you look at here, you have 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. So this is a square, the big shape here. So if you have a square, you know that you have this line of symmetry for a square, this line of symmetry for a square, this diagonal here, and this diagonal here as well. So let me actually number them: 1, 2, 3, and 4. So you have 4 lines of symmetry. So let's start with the first one. So first one will be right down the middle here. Right here. So if this is your line of symmetry, that means I have to shade this box here, which is on the other side for the mirror image. This one is already shaded. This one is not shaded, so I have to shade this one as well. I have to shade this one as well. But the question states I can shade only one more small square. So that is not correct. So I erase this. Let's try the second one, which is this diagonal here. So for this, I'll have to shade this one on the other side. This one, I will have to shade this one actually. And for this one, I'll have to shade this one. So you're already above one. So this is not correct as well. So let's look at the third one, which is this one. So this I'll have to shade this square. For this, I'll have to shade this. Oh, sorry, this one is already shaded. So this is good. So for this, I have shaded this. For this, I've already got a shaded one. But for this, I have to shade this one here. And then again, for this, I'll have to shade this one. So this is again more than one. So this is not correct either. So the last one is this fourth one. So this is the line of symmetry. Now for this one is already shaded. For this, I'll shade this one. This one is split in half, so half on this side of line of symmetry, half on this line of symmetry, so I don't have to do anything else. For this one, I already have this one shaded. So this is the correct answer. You will shade this box and your line of symmetry will be one, exactly one, which is this line here. Question 9 is you're given values of P and Q. Evaluate the following, giving your answers in standard form. So P times Q would be equals to 8 into 10 power minus 6 multiplied by 2 into 10 power 11. So 8 twos are 16 multiplied by, you're multiplying them. So multiplying the 10s, so you'll add the powers. Minus 6 plus 11 would be 10 power 5. So to convert it into standard form, I need to move this decimal here. So this will become 1.6 multiplied by, so since I moved the decimal one place to the left, I will increase the power by 1. So this becomes 10 power 6. So 1.6 into 10 power 6. Part B is P divided by Q. So this is 8 into 10 power minus 6 divided by 2 into 10 power 11. So 2 times 1 is 2 and 2 times 4 is 8. So you get 4 into 10 power. So since you are dividing, you will subtract this power 11 from this minus 6. So you have minus 6 minus 11, which is 4 into 10 power minus 17. So this is in standard form. Part C is you have to find the cube root of P. So P is 8 into 10 power minus 6, and then you have to find the cube root, which is power 1 by 3. So I can bring this power in. So this becomes equals to 8 power 1 by 3 multiplied by 10 power minus 6 over 3. So cube root of 8 is 2. And this becomes 3 ones are 3. 3 times 2 is 6. 2 into 10 power minus 2. So your answer is 2 into 10 power minus 2. Question 10 is by writing each number correct to two significant figures, estimate the value of this. So if I write this in two significant figures, so this is the first non-zero value. So this 1 is my first significant figure and this 2 is my second. So after that, I have a value which is less than 5, 1 here. So I will round it down to 1200. Then divide by, this is 2 first and this is my second significant figure. So this is 9. So I'll round it up to 300 multiplied by, this is my first figure, significant figure, this is second significant figure, and then the next value is greater than 5 or greater than equal to 5. So this 4 will be rounded up to 5. So I'll get square root of 25. Now I will get 1200 divided by 300 into square root of 25 is 5. So I'll cancel out these zeros. 3 times 1, 3 times 4. So I'll get 4 over 5, which is 0.8. Question 11, here are the first five terms of a sequence. So 3 by 4, 7 by 8, 11 by 12, 15 by 16, 19 by 20. Write down the next two terms. So if you look at the numerator, the next term you add 4 to the numerator to get the numerator for the next term. So 7 plus 4, 11, 11 plus 4, 15. And you're doing the same in the denominator as well. You're adding 4 for the next term. 8 plus 4, 12, 12 plus 4, 16. So the next two terms, so if you add 4, 19 plus 4 is 23 and 20 plus 4 is 24. So the next term is 23 by 24, and then the next term after that will be add 4 here. So you get 23 plus 4 will be 27. So this will be 27, and then 24 plus 4 will be 28. So this will be 27 by 28. The kth term is 1199 by 1200. Find k. So now if you look at the denominators of each term, these are actually multiples of 4. So this is the first multiple, 4 divided by 4 for 1. So first term is 4 times 1. Second term is 4 times 2. Third term is 4 times 3. And so on. So fifth term is what? 20 divided by 4, 5. So if you divide by 4, you get the term number. So if you divide 20 by 4, which is 5, this is the fifth term. So 28 divided by 4 is what? 7. So this is the seventh term. So you're given the kth term is 1200. So if you divide 1200 by 4, you will get 300. So this is the 300th term. So the value of k is 300. Find an expression in terms of n for the nth term. So you can see that all the denominators are multiple of 4, right? So for n equals to 1, your denominator is some number which is 3 and then 3 over 4. For n equals to 2, your denominator is numerator is 7 and then 8. So how do you get 8 for n equals to 2? You multiplied 2 by 4. So your denominator is always 4n. Your n is 1, you get 4. If n is 2, you get 8. If n is 7th, so 7th term is this one here, you get 28, right? So if you have your nth term, your denominator value will be simply 4n because all these are multiples of 4, starting by the first multiple, second multiple, third multiple, and so on. And then if you look at the numerator, your numerator value is always just 1 less than the denominator. So 3 by 4, 3 is 1 less than 4. 7 by 8, 7 is 1 less than 8. And simply like 27 by 28, this numerator 27 is 1 less than the denominator. So for the nth term, your denominator is 4n and then minus 1 because the value of numerator is 1 less than the denominator. So denominator is 4n, you get 4n and then minus 1. So your nth term is 4n minus 1 over 4n. Question number 12 is each interior angle of a regular polygon is 175 degree. Find the number of sides in the polygon. So since it's a regular polygon, all the angles will be 175 degree. So if you, let's call the number of sides equals to n. So what's the sum of your all the angles? Since one angle is 175, so 175n will give you the sum of all the angles of this regular polygon. And you also know that sum of interior angles of any polygon is given by n minus 2 into 180. So if this gives you the sum, this also gives you the sum. So these two values should be equal. And now you can solve for n. So 175n equals to 180n minus 360. And then if I take this 180n to the other side, I get minus 5n equals to minus 360. These minus and minus cancel out. So n equals to 360 by 5, which is 5 times 7 is 35, 110, 2. So your answer is 72. So this regular polygon has 72 sides. So question number 13 is the scale diagram shows two islands A and B. The scale is 2 centimeter to 1 kilometer. Write the scale 2 centimeter to 1 kilometer in the form 1:n. So first we can convert this kilometers into centimeters. So 1 kilometer will equal 1000 meters since each kilometer has 1000 meters, and then we can multiply this by 100 because 1 meter has 100 centimeters. So this will be equal to 1000 into 100 centimeters. So this is 1 2 3 4 5 zeros. So 1 2 3 4 5. So this is 100,000. So now you have the scale here as 2 ratio 100,000, but you want to convert it into 1 ratio n. So you can divide by 2 on both sides. So 2 divided by 2 would be 1, and then 100,000 divided by 2 would be 50,000. So your ratio is 1 ratio 50,000. Part B is by measurement find the bearing of B from A. So bearing of B from A would be this angle like this. But since my protractor only goes up till 180 degree, what I can do is I can measure this small angle here and then subtract it from 360 degree to get this bearing of B from A. So let's measure this smaller angle. I can place my protractor at the center here and then rotate it so that the 0 degree line is directly to the north. So now if I look at this, This angle is 70, 71, 72, 73 degrees, almost 73 degrees. In fact, a little above 73. So we can write it as 73 degrees. So this angle here is 73. So bearing of B from A would be equals to 360 minus 73, which is equals to, so if I subtract 73 from 360, I get, so I have to carry from here. So this results in 2, this becomes 15, and this becomes 10. So 10 minus 3 is 7, and then 15 minus 7 is 8, and then 2 minus 0 is 2. So this is 287, your bearing of B from A. Part C is an island is at C. An island at C is on the northern side of AB. So let me quickly erase this. So northern side of AB means it's above AB somewhere here. Uh, it is 3 kilometers from A and 2.5 kilometers from B. Use a ruler and a pair of compass to construct triangle ABC. So it's 3 kilometers from A. So we know that 1 kilometer is 2 centimeters. 2 centimeters. So how many centimeters will be 3 kilometers? So you multiply by 3. 3 kilometers will be 6 centimeter. So your length AC is 6 centimeter. And similarly, we can find the length AB. So B is 2.5 kilometers. Oh, sorry, C is 2.5 kilometers from B. So 1 kilometer is again 2 centimeters, and we have to find 2.5 kilometers. So that would be simply you multiply by 2.5. So you get 2 into 2.5 is 5 centimeters. So your length BC is 5 centimeter. So this point C is north of this line AB, which means it's above. AC is 6 centimeters and BC is 5 centimeters. So I can easily draw this using my compass. I can find the location of point C. So let's first start with A. So AC is 6 centimeters. That means I will open up my compass to 6 centimeters. So this is about 6 centimeters. So uh, I will place it at A here at the center A. And then I will draw an arc north of AB. So this arc is 6 centimeter away from A. So let's draw this arc here. And then BC is 5 centimeters. So I can bring my compass back and open it up till 5 centimeters. So I'll place it at 0 here. Make sure it's completely aligned with the ruler and then open it up till 5 centimeters. Now I will place it at B. So I will place it here at B and then draw an arc. So now the intersection of the two arcs uh, give you the point C, which is 6 centimeters from A. So this will be your point C, which is 6 centimeters from A and 5 centimeters from B. So now you can draw the lines AC and BC to get your triangle ABC. So this will be your line BC. So this one is BC, and then your AC will be like this. So this is your triangle ABC. Question number 14 is the diagram shows a triangular prism. The measurements are in centimeters. So on the grid below, complete the accurate drawing of a net of the prism. So if you look at this diagram, you're given some part of the net already drawn here. So if you look at this length here, this is 4 centimeters, and this length here is also 4. So if you look at this diagram, this is the square here. So this square here, let me draw it. This is the 4 by 4 square that is represented in the net. So this 4 by 4 is this one. And then the next one is this is 4 centimeter this way, and this way this is 3. So if you look at the one on the back side there, this one, this is 3 centimeter in this direction, and since this is 4, so uh, this and this are 4 as well. So this top one is 4 centimeters as well. So this is the rectangle which has one length 4 centimeter and one length 3 centimeter, which is represented by this rectangle here in the net. So let me draw that one in another color. So this is the one I'm talking about, this green one here, which is at the back. So if you look at, so this one is at the bottom, this one is at the top. So what we are doing essentially is we are pressing, if you press on the prism on the top, if you if you press it on from the top and try to like lay it flat down, this blue rectangle will move in this direction, right? And the green one on the back will move in that direction. And if you look at on from the top, then you will have the 4 by 3 rectangle above this 4 by 4 as shown in the net. So you're basically pressing from the top, and this is moving in this direction and this is moving in this direction to lay flat on the ground. And then there are two triangles, one on this side. So let me mark this here in yellow. So this triangle here and this other triangle on the back side here. So this is the one on this left side. The one length is 4 and the other length is 3. So this length here is 4 and the other length here is, this one is 3. So how do how did this triangle end up like this in the net? So if you break off this side here, this 4 centimeter side, and break off this 5 centimeter side, so imagine that this is not attached here and not attached here, and that means it's free to rotate along this side. So you will open this up like this, and it will be right beside this 4 by 3 triangle which you have on the back here represented by green. And similarly, if you break this the other one, the other triangle on the other side, if you break this side and break this side, that means your triangle is free to like rotate along this side, this dotted line here. So it will be the exact mirror image on this side. It will rotate out and it will rest alongside this green rectangle at the back. So your the triangle, this triangle will be represented in a similar fashion. So you will have 4 in this direction, and then you will connect this here, and you will have 3 centimeters in this 3 centimeter length here, and this will be your length 4 centimeter. And now the only one left is this bottom one. So let me color this in black here. So this is your 5. So remember this was 5 here. And so one side of this rectangle is the bottom base is one length is 5 and the other length is 4 centimeter here. So you have this length which is 4 centimeter. So the other length is 5 centimeter. And if you look at this rectangle, you break it off with from this edge, from this edge, and from this edge. So it only remains attached along this edge, the one at the back, which is dotted line here. So it will, if you break it off from here, here, and here, it will kind of fall down like this, correct? So it will open up. If it's like you open up the bottom of this prism and then rotate it up so it can lay flat somewhat like this. So it will open up and rotate along this edge and lay flat. So if you're pressing on the top, this will be your bottom 4 by 4 rectangle, sorry, square. Then above that is your back green 3 by 4 rectangle. And then on top of that will be your 5 by 4 rectangle where this 4 centimeter side is the common side. So this 4 centimeter side is the common side. And then the other side is 5 centimeters. So I will draw a straight line 5 centimeter, and this will be 4 as well, and then this will be 5 centimeter as well. So this is how you will complete the net of this prism. Part B is find the total surface area of the prism. So surface area would be, these two triangles are identical, so the area of this triangle is 1 by 2 into base into height, so 1 by 2 into 4 into 3, and there are two such triangles, so I will multiply it by 2 plus the area of this rectangle plus this rectangle plus this rectangle, which is 5 by 4. So area of this is 4 into 4 plus area of this is 4 times 3 plus area of this is 5 times 4. So this 2 and this 2 cancel out. This becomes 12 plus 16 plus 12 plus 20. So this is 20, 30, 40, 50, 56, 58, and 60. So your answer is 60 centimeter square. Question number 15 is, each week Henry records the number of units of gas used in his house and the mean temperature outside. 10 of his results are shown in the table. On the grid below, complete the scatter diagram. The first 5 results have been plotted for you. So this is 12.2 degrees Celsius and the consumption is 140. So your these 5 points that are shaded in gray have already been plotted. So we have to plot the rest of the 5. So this is 4.4 degrees Celsius and number of units consumed is 600. So between 4 and 5, you have 5 blocks. That means each small block represents 0.2 degree. So 4.4 will be 2 blocks right of 4. So this is 4.4, and then we have to go up till 600. So this is the line I'm looking at. Basically, 2 boxes to the right of this 4 line. So this is 4, this is 600. So this is 4 and 600, and then I move 1, 2 blocks to the right, 2 small blocks to the right. So this is my point, 4.4 and 600. The next one is 5.6 and 500. So 500 line is this, 5 line is this. So this is 5 and 600, 5.2, 5.4, and then 5.6. So this will be your 5.6 and 500. Then is 6.8 and 560. So so this is 100 and 1, 2, 3, 4, 5 points. So 5 points, 5 small blocks and 100 change. So that means each small blocks represents 60. So you have to go till 560, which means 3 small blocks above this 500. So this is your 560 line, and you have to go up till 560 and 6.8. So this is 560 and this will be 6.8, one small block before this line of 7. So this is 6.8 and this is 560, then 580, then 600. So this is correct. So this is my, so I've done this one, and this one. Then this is 9 and 410. So 9 is this, and then 410 would be in the middle of this small block. So this is 400 and then one block above is 420. So I have to mark the point right in the middle of this box. So 9 and 410. And the last one is 10.6 and 320. So this is 10, 320, this is 10 and 300. So you have to go till 10.6. So 10.2, 10.4, 10.6, and then 320 is one line above, one small block above. So this is 320 and 10.6. So you have completed the scatter diagram now. So what type of correlation does your scatter diagram show? So if you look at the x-axis, your temperatures are increasing, but the number of units of gas used is decreasing. So one value is increasing, the other value is decreasing. So it's a negative correlation. So negative correlation. Part C is draw a line of best fit on the grid. So to draw the line of best fit, what I can do is I can look at these points, and so if I join this second point with this last one, basically what I want to do is I want to have same number of points above and same number of points below the line. So let's see, let me try to draw a line that basically goes through this point here. Let me see if I can. So if I join these 2 points here like this, so my line is passing through 2 points. So let me just leave it here. So let's see. My line is passing through this point and through this point, and I have 1, 2, 3, and 4 points below the line, and then I have 1, 2, 3, and 4 points above the line as well. So this seems like a good fit for this scatter plot. Part D is use your line of best fit to estimate the number of units used for 1 week when the mean temperature outside was 7.6. So now I have to see where this line intersects the uh, x value of 7.6. So this is 7, 7.2, 7.4, 7.6. So basically small blocks to the right of 7 or two small blocks to the left of 8. So if I go two small blocks left of 8, so this is 400, and then this is the intersection point. So this line here is 7.6, and it's intersecting around about 420, because this is one small block above the line of 400. So you can say the number of units of gas used is 420. So 420. Let me actually mark it here as well. So this is the 7.6 line. 7.6, and it intersects at this point. So this value here, uh, let me draw this correctly. So this line here is represented by 420 on the, so this is 420 on the y-axis. So your answer would be 420. Question number 16 is find the possible values of x given that x is an integer and this value here. So 15 greater than 2x minus 3 and less than 22. So to find the value of x, I will add 3. So I can remove this 3 and I will add 3 on both sides of the inequality. So this will become 15 plus 3, 2x, and then 22 plus 3, because this minus 3 plus 3 is 0. So this is 18, 2x, and then 25. So if I divide by 2, On both sides here, I will get 18 divided by 2 is 9. 2x divided by 2 would be x, and 25 divided by 2 will be 12.5. So if x is greater than 9 but less than 12.5, so you have to give the integer value. Because x is an integer, find the possible values of x. So what are the integers between 9 and 12.5? So you have 9 here on the number line, and then 10, 11, 12, and then somewhere here is 12.5. So these, so since this is not a, this is greater than, not greater than equal to, so 9 is not included. So you have 10, 11, and 12, and then 12.5 is the top limit. So you can't have any other integer values. So your answer is 10, 11, and 12. Question number 17 is bag A contains 3 black and 2 white beads. Bag B contains 2 black and 4 white beads. A bead is chosen at random from bag A and placed in bag B. A bead is then chosen at random from bag B. Complete the diagram. So what you're doing is you're choosing one bead from bag A, putting it in bag B, and then when you choose a bead from bag B, you will have one additional bead in the bag B here that you had chosen from bag A in the previous turn. So let's look at this tree diagram. So probability of getting a black from this bag A is 3 by 5 because you have 3 blacks and you have total 5 beads in here. So if you get a black one here, that means you add that in here, right? So you will have 3 blacks in your bag B if you chose a black one from bag A. So that is why then if you choose a bead from bag B, what is the probability of getting black? 3 by 7, because now you have 3 blacks and your total is 1, 2, 3, 4, 5, 6, 7. So you have 7 beads and 3 blacks. So what is the probability of getting a white? So you chose a black from this, put it in this, which is this one. And then what is the probability of white? You have 1, 2, 3, 4 whites, and then you have 7 total. So 4 by 7. So now you also have to complete this one here, black and white. So now if you choose, let me erase this one. So now if you choose a white from bag A, what is the probability of choosing a white from bag A? There are 2 whites and there are a total of 5. So 2 over 5 is the probability of choosing a white bead from bag A. Now, if you have chosen a white one from bag A and you have put it in this bag here. So now what is the probability of getting a black one? So now you have this extra white one that you chose from bag A. So now you have 2 blacks. So 2 over how many total? 1, 2, 3, 4, 5, 6, 7. So choosing probability of choosing a black now is 2 by 7. And what is the probability of choosing white? You have 1, 2, 3, 4, 5 whites, and then again total 7. So your probability of choosing a white is now 5 by 7. So part B is find the probability that a black bead is taken from bag B. So probability of black from bag B. So how do you end up with a black one? If you end up here or if you end up here. So this is probability of getting a black from bag A and then getting a black from bag B. So let's call it probability black black BB, or you can go this route as well, or probability of picking a white one from bag A and then a black one from bag B. So this is white black. So this is, so in, I'm writing this, these are the bags. So this is bag A, this is bag B, this is bag A, this is bag B. So in both cases, you are ending up with a black bead which is taken from bag B. So in both of these, you have black from this bag B. So what is the probability of getting black and black? So this black and then this black. So 3 by 5 multiplied by 3 by 7, or probability of getting a white and then a black. So probability of getting a white is 2 by 5, and then probability of getting a black is 2 by 7. So multiply by 2 by 7. So this is 9 over 35 plus 4 over 35, which is 13 by 35. So probability that a black bead will be taken from bag B is 13 over 35. So question number 18 is in the diagram A, B, C, D, E lie on the circle. So all these points are on the circumference of this circle. AB is parallel to ED. ABE is 62, CDE is 127, and BEC is 40 degrees. Find the angle X. So if you look at this quadrilateral BCDE, let me mark this BCDE, and this. So this is a cyclic quadrilateral because all four vertices lie on the circumference of the circle. So you know the property that the opposite angles of a cyclic quadrilateral sum up to 180. So x plus this 127 should be equal to 180. So x is 180 minus 127, which is equals to 53 degrees. So this is 53. Find y. Let me erase this. So for y, if you look at this angle y here, and if you look at this angle BEC, so this angle BEC, they are in the same segment, and this is they're subtended by the same arc length, so these will be equal. So y will be 40 degrees because angles in the same segment are equal. Part C is find z. So let me just erase this. So if you look at these two parallel lines, AB and DE, uh, this 40 plus Z and this 62, these are two alternate interior angles. So let me actually highlight the relevant lines here. So this is one parallel line, and this is the other parallel line, and this is the line that is intersecting the two parallel lines. So this line here intersects these two parallel lines. So this angle and this 62-degree, they are opposite alternate interior angles, sorry. So you know the property that alternate interior angles are equal. So this 62 will be equal to this angle here, which is z plus 40. So z plus 40 will equal to 62 degrees. So z will be 62 minus 40, which is 22 degrees. So z is 22. So question number 19 is in the diagram PQ intersects LM at point O. So this line PQ and this is the line LM, and they intersect at this point O. On the diagram, construct the locus of points that are equidistant from the lines PQ and LM. So equidistance from the two lines which we have here as PQ and LM. So this is PQ and this is LM. So we know that whenever we draw locus of points that are equidistant from two lines, we actually construct the angle bisector. So you have seen angles such as this. So if you have this line AB and this line BC, so if you want to draw a locus of points that is equidistant from AB and BC, what you do is you draw the angle bisector by drawing this arc, then placing your compass and draw an arc like this. And then if you join this through this, you get the angle bisector of this angle ABC. Now this is pretty similar. You just have this line extended and this line extended the other way as well. So this is the other angle. And since these are two straight lines, these are actually vertically opposite angles. So this angle here is equals to this angle here. So angle MOQ is equals to angle POL. So if you draw the angle bisector for this one and then just extend it to the other side, you will actually draw the angle bisector for this angle as well. And similarly, we have two other angles. So we have four angles that are formed between these two lines. So these are the other two angles, and these are also vertically opposite. So if you draw the angle bisector for one of them, like this, placing an arc and then joining these 2 points, and if you extend it below, you will get the angle bisector for this as well. So you have to basically draw the angle bisectors for all these 4 points, but all these four angles. But since these angles are pairs where this is equal to this and this is equals to this, you can just draw one angle bisector here and then extend it to the other side, and similarly draw one here and then extend it to the other side. So those four angle bisectors, one for each of these angles, will give you the locus or points that are equidistant from line PQ and LM. So let's go ahead and actually draw those angle bisectors. I will use my compass here. So let me place this here at the center and then just open it up till this point, which is, and then you have to draw an arc from this edge, this line, to the other line that forms this angle, and then place this angle where this arc intersects the line. Make sure your compass length is not changed. Draw another arc like this, then place it on the other side and draw another arc. So now this point, if you join this point with this point O, you will get the angle bisector. So let's join. So let me actually make this bigger so that I can draw it to the other side as well. So this is one of your angle bisectors for both of these angles, angle MOQ and angle POL. Now let's draw the angle bisector for POM. I'll again place the compass at this center O and then draw the arc. So let me just make it a little bit bigger so that I don't overlap with this arc. So draw it from one edge to the other. Place it here and then draw the arc here and then place it on the other edge and then draw the arc again. So let me just make the other arc a bit longer so that I have a good intersection point. So now if I join this point with point O, I should get the angle bisector, other two angle bisectors. So let me actually make sure that this is aligned properly. And then I can draw this line. So now you have these two. So this is not actually passing through this center, but you get the point. Slightly off, but that's fine. Uh, so now you have these two uh, pairs of angle bisectors. Uh, so this angle bisector is for MOQ as well as MPOL. And then similarly for POM and LOQ is this one. So these four angle bisectors, this here, this here, and this here, represent the locus of points that are equidistant from lines PQ and LM. Part B is construct the locus of points that are equidistant from point O and Q. So now you have 2 points. So you draw the locus, you have to draw the perpendicular bisector of line OQ. So you can draw it by placing your compass on one of the edges, which is Q in this case. Make sure you open it up, open up the compass more than halfway, more than half the length of this line. So line OQ is this, and I've opened it up more than half the length of this line, and I'll draw an arc here. And I will also draw an arc on the top side. And then I will place my compass on this other point O and draw the other two arcs here at the top and then at the bottom. Now if I join these 2 points here, I will get the angle bisector of line OQ. So this line here is the locus of points that are equidistant from O and Q, which is the perpendicular bisector of this line OQ. The next question is P is the point -3, 4, Q is the point 5, 1, M is the midpoint of PQ. Find the coordinates of M. So since you know that M is the midpoint, you can find the coordinates of midpoint by using the formula x1 plus x2 over 2. So this will give you the x coordinate. And then y1 plus y2 over 2. This will give you the y coordinate of the midpoint. So let's say that this is x1, y1, and this is x2, y2. So this is -3 plus 5 over 2, and then 4 plus 1 over 2. So this gives you 5 minus 3 is 2 over 2, and 4 plus 1 is 5 over 2. So this is actually 1, and this is 2.5. Find the gradient of PQ. So you know that gradient is y2 minus y1 over x2 minus x1. So y2 is 1 minus 4, 1 minus 4 over 5 minus -3, 5 minus -3. So this becomes -3, and this 5 minus minus becomes plus. 5 plus 3 is 8. So -3 over 8. Part C is R is the point -6, 0, O is the point 0, 0. Which of the points R or P is closer to O? So if you have this axis and your O is basically the origin, and R is this point -6, and then Y value is 0. So this is on the x-axis. And then your P point is -3, 4. So it will be somewhere here, -3, and then 4 is this. So this will be your point P here. So now what you can do is to show which one is closer to O, we can find the distance OR and OP, and whichever distance is less, that point is closer to O. So OR is pretty straightforward. You know that this is just a horizontal distance and this is at -6. So the length OR is 6. And then for length OP, you can use the distance formula to calculate the length. So OP, so the length would be under root of y2 minus y1 whole square plus x2 minus x1 whole square and then whole square root. So you know that p is minus 3 and 4. So let's say this is x2 and y2, these values, and then 0, 0 is x1 and y1. So y2 minus y1 is minus 3 minus 0 whole square plus 4 minus 0 whole square root. This is square root of 3 square plus 4 square, which is square root of 9 plus 16 is 25, which is 5. So OP is equals to 5. So now you can say that point P is closer because this distance OP is less than OR. So P is closer to O. Question number 21, part A, evaluate 9 power 1 plus 9 power 0. So 9 power 1 would be 9 and 9 power 0 would be 1, which is equals to 10. Find n where 4 power n equals to 2 power n minus 1. So to compare the powers, we need the same bases on each side. So I have 2 on as a base on this side. I can write 4 as 2 squared and then 4 power n equals to 2 power n minus 1. So if I open the brackets, these powers multiply. So 2 power 2n equals to 2 power n minus 1. So now the bases are same. We can equate the powers and find the value of n. So 2n equals to n minus 1. And then if I bring this n to this side, this becomes n equals to minus 1. Question 22, you're given a universal set, then set P is x has x equals to 0, 1, 2, set Q has y equals to 0, 2. List the members of P intersection Q. So P intersection Q means the values that are present in both the set P and the set Q. So 0 is present in both, so 0 will be one value, and then 1 is not present in Q, but 2 is present in both, so 0 and 2 are the members of P intersection Q. Part B is find number of elements in P complement union Q. So let's first write down what is P complement. P complement is everything outside of P. So 0, 1, 2 are part of P. So 0, 1, 2 are part of P. So they will not be part of P complement. All the rest of the numbers will be. So 3, 4, 5, 6. So P complement is 3, 4, 5, 6. And then your Q is this 0 and 2. So what you have to do the union of Q and P complement. So your Q is 0 and 2. So P complement union Q would be you basically combine both the elements, combine elements in both the sets, making sure you do not repeat any element. So there's already no common element between the two. So this will be 0, I'll write the Q elements of Q first, 0, 2, and then 3, 4, 5, 6. So, but remember you have to give the number of elements in this set, not the set itself. So the number of elements, how many elements are there? 1, 2, 3, 4, 5, 6. So there are 6 elements in P complement union Q. Part C is R equals to this set Z, which is equals to 2x plus y, where x belongs to the set P and y belongs to the set Q. List the members of R. So x belongs to P and y belongs to Q. So you have to basically find all the possible element combinations of x and y and then substitute them here to find the value, corresponding value in R. So what I can do is I can basically write the elements in a table. So let's write 0, 1, 2. So this is set P. And then let's write the elements of set Q here. What are set Q? 0 and 2. So now I have to compute these values, which basically give me all the possible combinations of elements in set P and Q. So let's take this first value here. So this is basically x, oh sorry, this is y, and this is x belonging to P. So my z equals to 2x plus y. So if both are 0, both x and y are 0, so 0 plus 0 is 0. So I'll get, let me write them in green. So this elements in green are part of z. So what if x is 1 and x is 1, y is 0. X is 1 is 2 times 1, 2 plus 0, 2. So this will be equal to 2. What if x is 2 and y is 0? So 2 times 2 is 4, 4 plus 0, 4. What if x is 0 and y is 2? So 2 times 0 is 0 plus 2 is 2. X1 and y2. So 2 times 1 is 2, 2 plus 2, 4. And what if x is 2 and y is 2? So 2 times 2 is 4, 4 plus 2, 6. So R is basically these elements. So you make sure you do not repeat the elements. So you have 0, then you have 2, and then you have 4, and then you have 6. So this is your answer here. 0, 2, 4, 6 are the elements in the set R. Question number 23 is express this as a single vector. So we can simplify this by first multiplying these scalar quantities inside to these corresponding vectors and then doing the addition and subtraction. So 2, 1 minus, if I bring this 3 inside, this becomes minus 3 and 6. Plus, if I bring this 2 inside, this becomes 0 and minus 4. I can solve this first. So 2 minus minus 3. So 2 plus 3 is 5. 1 minus 6 is minus 5. Plus 0 and minus 4. 5 plus 0 is 5. Minus 5 minus 4 is minus 9. Part B is you have to do this matrix multiplication. So this matrix has one row and two columns. So this is 1 by 2 matrix. And this has two rows and three columns. So this is a 2 by 3 matrix. So you know that you can do this multiplication because this the column of the number of columns of the first matrix is equal to the number of rows of the second matrix. So if you cancel these out, you get 1 by 3. So your resulting matrix would be a 1 by 3 matrix after you do this multiplication. So let's start. So you have to multiply this row by this column. So first element multiplied by the first element, and then the second element multiplied by the second element, then you add them together. So this is 2 times 0 plus minus 1 times 3, minus 1 times 3. So then you will do the same with the second column, which will be your second value in the resulting matrix. So 2 times minus 1, 2 times minus 1 plus minus 1 times 1, minus 1 times 1. And then the last one, 2 times 2, 2 times 2 plus minus 1 times minus 3, minus 1 times minus 3. So 2 times 0 is 0. 0 plus 3 times minus 1 is minus 3. So this is minus 3. 2 times minus 1 is minus 2, and then minus 1. And then 2 times 2 is 4, and then minus 1 minus times minus 3 is plus 3. So 4 plus 3. So this is minus 3, minus 3, 7. So this will be your answer, minus 3, and 7. And you can see that we calculated before we did the multiplication that we will get a 1 by 3 matrix, 1 rows and 3 columns, and here you have 1 row and 3 columns. So question number 24 is a train travels between two stations, starting and finishing at rest. You're giving some information about the journey. On the grid below, draw the speed time graph for this journey. So let's look at this information. So the first point is it starts from rest. It accelerates uniformly from rest for the first 30 seconds until it reaches a speed of 20 meters per second. So at time t equals to 0, you're starting from rest, so your speed is 0. So this will be your point on the speed time graph. And then it accelerates uniformly for the first 30 seconds until it reaches 20 meters per second. So after 30 seconds, it has reached a speed of 20 meters per second. And since it accelerates uniformly, that means the gradient of your speed time graph, it's constant throughout, which means it's a straight line. So let me connect this with a straight line from this point up till this point here. So this is a straight line because it accelerates uniformly, meaning the gradient of your speed time graph is constant. And the second point is it travels at a constant speed of 20 meters per second for the next 60 seconds. So for the next 60 seconds means from 30 plus 60. So 30 plus 60 is 90. So it travels at a constant speed for the next 60 seconds. That means the speed is 20 meters per second. It travels a constant speed of 20 meters per second for the next 60 seconds. So up from 30 seconds till 90 seconds, the speed is constant at 20 meters per second. So this will be another straight line from this point up till this point here. And then it slows down uniformly for the last 20 seconds until it stops. So for the last 20 seconds, it means it 90 seconds is here. So it decelerates for the next 20 seconds until it stops. So 90 plus 20 would be 110. And at 110, you are at the train completely stops. So that means the speed is 0. And again, it slows down uniformly, which means the graph has a constant gradient. So that means this will be another straight line between this point and this point here. So this will be your speed time graph for the train's journey. Part B is calculate the distance between the stations. So your distance will be this whole area under the speed time graph. So this is a trapezium. So my distance would be 1 by 2 into the height is 20 into sum of parallel sides. So this side here is 90 minus 30, which is 60. And this side here is 110. 60 plus 110. So this cancels out. 2 times 10 is 20. So 10 times 60 plus 10 is 170. So then this is 1700. So 1700 meters is the distance between the two stations. So question number 25 is in the diagram A, D, B, and ACF. So A, D, B, and ACF are straight lines. BC, so this BC intersects DF at E. So this is the intersection point of these two lines, BC and DF. And then AC ratio CF. So AC ratio CF is 2:1. And then dB is P, and then there are a few others that are vectors that are given as well. So part A is express AB in terms of P. So AB is this vector here. So we are not given any information about this AD. So, but we know this vector here. Let me make sure I don't overlap. So we know this vector here AC, which is 3p plus 5q. And we know this vector BC would be 3q, which is BE. BE is 3q, and then EC is 2q. So this whole thing is in this direction 5q. So in opposite direction, it will be minus 5q. So in this direction, this will be minus 5q. So I can write vector AB as vector AC C plus vector CB minus vector BC or plus vector CB. So let me just write vector CB. So AC is what? 3P plus 5Q, 3P plus 5Q plus CB is what? Minus 5Q, minus plus minus 5Q. So 5Q minus 5Q is 0. So this is equals to 3P. So in terms of P, vector AB is 3P. Express CF in terms of P and or Q. So CF is this vector. And we are given that AC ratio CF is 2 ratio 1. So that means AC is twice the length of CF. So that means AC is 2 times CF. So CF is basically 1 by 2 times AC. And we know that AC is 5P plus, 3P plus 5Q. So this is 1 by 2 into 3P plus 5Q, which is 3P, 3 by 2P plus 5 by 2Q. So 3 by 2P plus 5 by 2Q. Part C is express EF in terms of P or Q. So EF is this vector, this one here. And I can write EF as this vector EC plus this vector CF that we found in the previous part. So I can write vector EF will be vector EC plus vector CF. So EC is what? 2Q plus CF is this that you calculated in the previous part, 3 by 2P plus 5 by 2Q. So I can add these terms which have the same variable Q with them. So if I take the LCM, I get 2 as the LCM. So 2 times 2 would be 4Q plus 5Q plus 3 by 2P. So this would be 3 by 2P plus 9 by 2Q. So 3 by 2P plus 9 by 2Q. Part D is EF equals to K times DE. So this is DE here. So EF is K times DE. Find the value of K. So I can first find this vector DE easily. DE is this vector, DE is this vector plus this vector. So I have to find DE in terms of P and Q because I know the vector EF in terms of P and Q. And then I can do the comparison to see the value of K, to find the value of K. So DE is equals to DB, this here, DB plus BE, which is DB is what? P plus BE is 3Q. So your DE is P plus 3Q. Now I'm given that EF, so EF is K times DE. So now if I replace the value, so what is EF? EF is this 3 by 2P plus 9 by 2Q equals to K times DE. K times what is DE? P plus 3Q. K times P plus 3Q. And from here, I can actually find the value of K. So what I can do is I can represent this in terms of some constant multiplied by P plus 3Q. So if I take 3 by 2 common here, so let's say if I take 3 by 2 common here, what do I get inside? I get P plus 3Q is equals to K times P plus 3Q. So now these two terms are exactly the same. That means this K must equal to 3 by 2. So K is 3 over 2. So This was the last question for this paper. This was October, November 2018, paper 1-2.